Welcome back, everybody. Today we're going to be moving on to section 3.5, which is graphing in intercept form. Again, if we look at our standards list, we've done almost all of these, but the one we're kind of hitting here is we're just looking at like the different forms about our quadratic function. We've got vertex form, which was up here. We've got standard form, and now we're going to have intercept form, and all of these different forms tell us different things about our functions. In those functions, we can still do all of our key features, and then at the end of the chapter, which is going to be section 3.7 that we haven't gotten to yet, is when we're actually going to hit this guy and this guy. So if you're sitting there going, well, when are we going to do that? That's going to be in our next section, but we're still going to focus in this lesson on another form of our quadratic function that can tell us information about it. So section 3.5, graphing quadratic functions in intercept form. Intercept form is also called factored form, which, if you remember from chapter 2, we could write a polynomial expression in either standard form or factored form, and they're kind of opposites of one another. So in the last section in 3.3, we did standard form where we could find the vertex and the axis of symmetry. So now we're going to look at intercept form, which is factored form, and how we can find those same things. So first of all, intercept form down here, f of x equals a. There's still that same a value. No matter what form we're in, a is still the same thing. And then we've got x minus p times x minus q. Now, first things first, if we are in intercept form, this is factored form. Okay, so if we want to find the x-intercepts, which is the biggest thing, this finds x-intercepts. So if we want to find x-intercepts of our graph, which is where our graph hits the x-axis, you're going to want intercept form. And remember how in the last one we said that this is the same thing as y? If you're thinking about a graph, what is the y value at your x-intercept? And the answer to that is 0. So 0 equals, if I'm trying to find my x-intercepts, a times x minus p times x minus q. Now I'm looking at factored form. I have this thing equal to 0, so I'm going to use my zero product property. Before I do that, I don't like my a value, so I'm going to divide both sides by a. So 0 equals, and then I'm going to have my x minus p times my x minus q. Then I can use my zero product property and say x minus p equals 0, x minus q equals 0. Add your p, so x equals p. Add your q, so x equals q. And right here, these are your x-intercepts of your graph. Your x-intercepts are your p-value and your q-value. Now, the other thing to keep in mind is if you're looking at intercept form, do you notice this is a minus p? But your x-intercept is actually at positive p. This is a minus q, and your x-intercept is actually at positive q. So kind of like when you're graphing in vertex form, and you've got that left or right movement, and it's the opposite of what you would think, kind of the same thing here. Now, there's one other thing we're going to write down, and this will all make more sense when we actually do an example, is your axis of symmetry. So x equals p plus q divided by 2. And keep that in mind. Write it down, and like I said, once we do an example, that'll make more sense. Example 1, graph each function, describe the domain and range. So letter A, we have f of x equals negative x plus 1 times x minus 5. Now that is an intercept form. Because it's an intercept form or factored form, that means we're going to find our x-intercepts. Now, we can skip a couple steps here, but really what we're doing is we're going to say, okay, well, my y value for my x-intercepts are going to be 0. So 0 equals negative x plus 1 times x minus 5. Then I would get rid of my negative by dividing both sides by negative. So 0 equals x plus 1 times x minus 5. Then I would apply my zero product property. X plus 1 equals 0. X minus 5 equals 0. Subtract your 1. X equals negative 1. Add your 5. X equals 5. And you just found your x-intercepts. Okay, the easier way to do that is just look up here and say, oh, okay, x plus 1, I've got a negative 1. X minus 5, oh, I've got a positive 5. And those are your x-intercepts. Now, in order to find your vertex, because when you graph, you need at least 3 dots. You need a vertex and you need 2 others. We got to find the middle. So if those are your 2 x-intercepts, aren't parabolas kind of symmetric? So they have a middle. So what I'm going to do is I'm going to say, okay, well, I'm going to go 1, 2, 3, 1, 2, 3, which takes me to 2. If I kind of like just hop in the middle. So I know my axis of symmetry is at x equals 2, which means my vertex must lay somewhere on that line. Okay, now the part that I didn't do here algebraically, I just showed you graphically, was remember back here, I said that the axis of symmetry was x equals p plus q over 2. Really what you did there was you did negative 1 plus 5, which is 4. That's your p plus q. You divided it by 2, which gave you 2. So that's how you do it algebraically. I usually just look at the graph. Now, if I want to find where my vertex actually is, and I know x equals 2, this is where we're going to go back and we're going to substitute in. So y equals, and then we're going to substitute our x, and we're going to substitute our x. So y equals negative x plus 1 times x minus 5. So y equals negative 2 plus 1 is 3. 2 minus 5 is negative 3, which is going to give me negative, not positive, 9. So my vertex must be at 2, comma 9. 2, 9. So 2, 9. Now, at this point, you are absolutely ready to go draw this graph. You've got the vertex, you've got the 2 x-intercepts, draw the graph. But if we want, we can be even more specific. And why is because of our a value. A value is still the same. A value is the same in vertex form, standard form, or intercept form. And that's going to tell you over 1, down 1, because there's a negative. So from my vertex, I could go over 1, down 1. I could go over 1, down 1, and I could graph. And then we're going to go like this, and then we're going to go like this, and that's the graph. Now we have to describe the domain and range. Domain, left to right, all your x values, all real numbers. Range, low to high. So how low do we go? Negative infinity. How high do we go? That's up here to our vertex value of 9. So negative infinity up to 9. Use a bracket because we touch it, and we're done. Next example, letter B. P of x equals 2x squared minus 8. Now, if you take a really close look at this function is not in intercept form. This function is in standard form. So option 1 is we could use x equals the opposite of b over 2a to find the vertex. But because we're practicing intercept form, I really want to get this in intercept form. So what we have to do is we have to factor. If we are factoring, leading term must be positive, greatest common factor. So the leading term is positive, but there's a greatest common factor of 2. So p of x equals 2. And then I've got x squared minus 4. Then I'm going to look at x squared, which is x times x. I'm going to look at 4, which is 2 times 2. That goes into the difference of 2 squares, so x plus 2 times x minus 2. And then drop down your 2, So your function in factored form is p of x equals 2 times x plus 2 times x minus 2. If we want to find our x-intercepts, we just take our factors, okay? So x plus 2 equals 0, x minus 2 equals 0, minus 2, x equals negative 2, add 2, x equals 2. So our x-intercepts are at negative 2 and at positive 2. Okay, the reason I didn't consider this 2 sitting right here was because once we turn this into a 0, we're going to divide both sides by 2. He's going to go away. We're not going to worry about it. And then we're just going to have the 2 and negative 2. Now, got to find the middle because we got to find the vertex. So axis of symmetry, x equals. Find the middle. Over 1, over 1, over 1, over 1. We are at 0. Then, well, yeah, I'm at 0. That's great. But where on 0? So we're going to substitute back in. So y equals 2 times 0 squared minus 8. And I always substitute back into the original function, not my factored or anything over here. Because if I go back into the original function, then I'm less likely to probably make a mistake with some of my work that could have happened over here. So y equals 2 times 0 squared. 0 minus 8 is negative 8. So I know that my vertex is at 0, negative 8. So I'm going to come down here, 0, negative 8. And again, at this point, you would be good to go ahead and graph. You have enough points. But if I want to get even more accurate, my a value is going to say go over 1, up 2. Over 1, up 2, over 1, up 2, and then I'm going to try my best to graph. And there's your function. Domain, all real numbers. Range, how low? Negative 8. How high? Positive infinity. Oops, sorry. Negative 8 with a bracket, positive infinity, and we're done.